This is Physics 101 project. Here I am.
This is Physics 101 project, and in this experiment I am trying to replicate the experiment done by Henry Cavendish. To the watcher of this video, I trust you with the knowledge of the force postulated by Sir Isaac Newton on the force of attraction between masses. As I said, you would know it as a constant times mass of first object, times mass of second object, divided by the distance square between these masses. And this experiment's aim is to find the constant in this formula. How am I going to do that? Is, as you see with this setup, there's a torsion bar attached with a mirror on it. This is right here, this torsion bar. I think you can see it. There are two large masses, there are two small masses, and this torsion bar is hanged with a wire to this lab stand right here. This, you see, is to protect this setup from air currents, and I blocked the roads with chairs to avoid people walking through here and creating other air currents that would hit sideways, that would hit the torsion balance sideways. And here I have a laser pointing at the mirror, and there is a horizontal paper with a ruler attached to it for me to measure where the laser hits the paper. How this works is basically, now because everything is subject to gravity of the earth, I can't do it on a vertical scale, so I have to look for the effect of gravitational attraction on horizontal level. So because of that, these all masses are placed on same level. The smaller mass you see here will be attracted to larger mass here, and the other smaller mass right there will be attracted to this larger mass right here. As a result of this wire will be twisted, and it will turn in a counterclockwise rotations like this. It would be like my finger rotating like this. However, because the wire will be twisted, there will be a resistive force due to this twisting, and wire will try to counteract the motion that happened because of the gravitational attraction between these two masses, and it will create a reverse direction torque in a clockwise direction, which will be like this. And at equilibrium points, these two forces will be equal to each other, and by equating these two forces, I'll be able to find the gravitational constant. And in order to find the equilibrium point, I need to find the angle of equilibrium. I'm using those to measure that, because this is a really susceptible experiment. Any minor change in here will result in a great change there, so it will enable me to measure the difference in a more accurate manner. As you see, the laser point is oscillating around a fixed point, and if I know the extreme points of this oscillation, such as let's say that it stopped at 20 centimeters and it stopped at 27 centimeters, its motion will be around 7 centimeters, and by looking at the distance from this paper to the torsion bar and the width of this oscillation, I can find the angle that this torsion bar makes with horizontal axis. So I can therefore measure it and eventually be able to find the gravitational constant.